Okay, today we are going to learn Ohm's law. Okay, Ohm's law is a formula used to calculate the relationship between the voltage and the current and the resistance in an electric circuit. Okay, normally it's applied to a single device. For example, we can put an ammeter here to measure a current, and we can put a voltmeter here, okay, to measure a volt. And then from here we can know the resistance of the bulb. Okay, Ohm's law, we write in the formula is V equals to IR. Okay, and if you read it, V is for voltage, okay, and I is for current, and R is for resistance. Okay, for units, okay, voltage is volt is for voltage, and amps is for current, and ohms is for resistance. And when we write the symbol ohms, okay, ohms is more special. We write it in this way, it's a capital letter. Okay, and this law is named after German physicist George Ohms. Okay, so one important thing from here is we need to learn to rearrange the formula. Okay, from V equals to IR, and we rearrange it to become I equals to V over R, and R equals to V over I. Okay, so how do we do that? Okay, normally you might see a triangle like that. Okay, but actually we don't like it. I hope you can learn this one from rearranging the formula using the algebra technique you learned before. Okay, for example, here we have a formula B equals to 5A plus 21, and we are going to rearrange A, make A become our subject. Okay, so how do we do that? Okay, so first thing, you need to get rid of 21. And how can we get rid of 21? Okay, so we need to minus 21 at the both side of the equal sign. So after you minus 21, the right hand side become B minus 21. Okay, and 5A plus 21 minus 21, and they become 0, nothing there. Okay, so now we have B minus 21 equals to 5A, and we want to get A, and we don't want 5, so what can we do? Okay, we divide by 5 at the both end. Oh, sorry, both side. Okay, so I have 5A divided by 5. I think you know the answer is A. Okay, and the right hand side become what? B minus 21 divided by 5, or over 5. Okay, so now we rewrite to the one conventionally. We put the subject at the left hand side, so A equals to B minus 21 divided by 5. So this is our answer. Okay, and how do we do that? Okay, we apply the same operation to the both sides of the equal sign. Okay, divide by 5, divide by 5, we do the same thing. Okay, by using this way, okay, we can get all the formulas we want. Okay, so for example, okay, Ohm's law, V equals to IR. We got one formula here, and if I want to make I the subject, and what can I do? I is the subject. Okay, so I need to get rid of R, so at the both sides I divide by R. Okay, so I copy the equation again, so V equals to IR, and divide by R, so I divide by R at here, and divide by R here, and R cancelled, so right hand side I only have I, and left hand side I got V over R. So I rewrite this one to conventionally subject at the left hand side, I equals to what? V over R. So we have the second formula. Okay, and the other one, if I want R become the subject, so what can I do? Again, I copy the equation, V equals to what? V equals to IR, and I divide it by what? I want to get rid of I, So I get I, so I divided I here. Okay, and then what do I have? I cancelled, so here become R, and I can rewrite to R equals to V over I. Okay, now we have three formulas. Now we have V equals to IR, and we have I equals to V over R, and we have R equals to V over I. Okay, and what does that mean? Okay, if we check this diagram, I think it's quite easy to understand. Okay, it's very intuitive. Okay, voltage, okay, is the pushing power. Okay, push the current go through. Okay, and current is kind of a flow of electricity. Okay, and ohms resistor. Okay, resistance is kind of to restrict, to stop the pushing power. Okay, so if we say, for example, we check this one, if the resistance is the same, so the stopping point, the stopping force or the resistance force is the same. When the pushing power, when the voltage increase, okay, the current will increase. And when the voltage decrease, becomes smaller, and the current will become smaller. So we say the voltage and the current, they are proportional. Okay, I think it's quite easy to understand. For denominator and numerator, they'll become, if the fraction keep the same, okay, they'll become bigger at the same time or become smaller at the same time. Okay, similarly, if we check a current, if we want to keep the current the same, okay, when I increasing the voltage, increase the pushing power, I need to increase the restricting power. Okay, I need to make it tighter, okay, to keep the flow the same because I'm pushing more powerful. And if the power is less, okay, and the resistance will be less. Okay, so again, they are proportional. If the current is the same, voltage and resistance, they are proportional. Okay, now if we want to keep the voltage the same, so same voltage, same pushing power. So if my resistance become bigger, the current will become smaller. Or you can say if my resistance becomes smaller and the current will become bigger. Okay, so these two, they are inversely proportional. Current and the resistance are inverse proportional. This is basically the relationship between voltage, current, and the resistance. Okay, and it's Ohm's law. So now we go to do some questions. Okay, before we finish the video, we need to say one more time for the symbols. Okay, for the symbols. For the symbols. Okay, so V is voltage, I is the current, and R is the resistance. And for unit, okay, for the unit, V is volt, and current is amp, okay, and resistance is ohms. Okay, and the unit also has a symbol. Okay, so for voltage, capital V, for amp, capital M, and for ohms, we write this way, ohms. Okay, so don't forget about these symbols because we need them to do the practice. Okay, so now let's look at some examples. Okay, so we have Ohm's law worksheet here for you to do some practice. Okay, so let's read the question. Okay, 1 and 2. So what is the current in a 160 volt circuit if the resistance is 2 ohms? Okay, so we want to look for what? We want to look for current when we know the voltage and the resistance. Okay, so after you read the question, you should know voltage is how big? Voltage is 160. Okay, and current is how much? We don't know current. Okay, and R is how much? R is 2 ohms. Okay, so we want to know I. Okay, so how do we write it? So I equals to, check the formula, I equals to V over R. Okay, so copy the formula first, and then you put the number in. So V is 160 and R is 2, and use your calculator, or you probably can do this one yourself already, 80. Now you need to include the unit. Okay, show your work. Okay, have a correct unit. So how do we do the unit? Okay, current for unit is amp. So write capital M. So circle your answer. Okay, so probably we'll write this one. Okay, so this is the question 1. I think you can do number 2, number 3, number 4 yourself. Okay, then I do number 6. Okay, for you, let's read the question. Okay, so we want to find the voltage. So voltage is the subject. Okay, and what do we know? Okay, so move to 6a. So this is the current, and we have the 5 ohms resistance. Okay, so I have to read the question. We don't know voltage, and the current is 6 amp, and the resistance is 5 ohms. So we want to know the voltage, and how can we find the voltage? Check the formula. Voltage is here. Okay, so we are going to use what? V equals to IR. So you need to write your formula first. So V equals to IR. Okay, and then you can put the number in. Okay, so I is how much? I is 6. And R is how much? R is 5. So 6 times 5 is 30. And including your unit. Okay, the unit for voltage is volt, capital V. Okay, so this is our answer. Okay, so I leave the rest to you. Okay, do the practice today. Okay, thank you very much.